Stories from data center. So yeah, who am I and what am I doing here? So I have this amazing slide of me in Germany. By the way, I hate Germany nowadays, but I used to live there, so I always use this picture in all my presentations. There's my Twitter tag or whatever, you find me everywhere. So I'm Kalle Sirkesalo. I work as a director of platform, this small team that upkeeps all of our Atlassian tools. I've been in Eficode for 4 years soon, and I have about 18-person team, soon 20. We are in 4 locations. So we have one in Copenhagen, and then 2 around Finland, and then Helsinki, of course. So Helsinki is not Finland, it's like completely different.
Right. It's 5. What?
5, what's the 5th?
2, 3.
Oh yeah, we have, yeah,
Holiday.
yeah, that's 3, and then Helsinki. And then I have Romania every now and then, but that's its own thing, like one of the guys goes to Romania for half a year or so. I used to be a technical person. I think I still am, but everybody keeps saying that I shouldn't do anything. But yeah, it just keeps happening. I keep programming or doing stuff like installing high available Atlassian stacks for all of our customers and discussing with them what's actually priority and how the shit works or how the stuff should work. And yeah, I'm kind of doing architecture job still. Like I really shouldn't, but yeah, it keeps happening. I used to work in game industry. That's my love and hate for IT. And then I took a bullet to the knee and moved to consulting and haven't looked back. So now I have worked for banking industries, car industry, pension insurance companies, operators, the list goes on, like media companies, whatever you can think about. I had like 52 projects in my first year as a consultant. I'm kind of a workaholic, if you don't notice. And yeah, the list keeps on going on. So yeah, I've been here when we were 70, and now we are 230 people as a company. So quite a long time in my opinion, but in Jukka's opinion, I've been just few years. So what's Atlassian DC and why data center and why I'm talking about it here? So yeah, we just installed few data center installations. So we have a running Bitbucket installation in one of the operators, as they saw it as business critical, that their kit keeps running. I will get back to why they saw it and what happens when you can't git push and stuff. And then we have small 5,000 user installation of JIRA and Confluence that have about 5,000 active users actually. So for example, Confluence crashed every week, so we had to fix it and do stuff for it. It just happens when you have enough load, and even bare metal can't handle it, like you have to have 2 big servers running it. So we kind of were running into this problem where we had to go big, like actually start scaling it. And that's what led us to researching what's Atlassian Data Center as we found it. And basically, that's what JIRA looks like when you migrate it. So first you have your server, then you have or something new running, then you put your load balancer on, and then you end up with some shared file system there. Then you throw your database as a cluster, possibly, and then you throw your another node on, and then you load balance it. That's what it goes like in perfect plan. I will go in detail how we actually rolled it out. This is actually a pretty bad picture because you have zero ways of rolling back. Like, if you're going to go to node, why would you go like this? Just move the data to other node and upgrade that, and then move the other node connected to it. But we'll get back to that. That's a spoiler. So with JIRA, it actually enables 0 downtime upgrades. So we've been doing few 0 downtime upgrades in test at the moment, and we're intending to do 1 before summer in production. But we're kind of scared because it's a brand new feature, and we're first in Nordics to be running this big of a JIRA data center. So it's kind of, even Atlassian is like, yeah, calling us and asking if we need help. And it replaces the JIRA server license that you know that halves the price every year. and it becomes subscription based. So every year you pay the price, so it's pretty expensive. But then again, as I will show later, it's actually possibly worth it. And it costs about $24,000 per 1,000 users. And that's JIRA in short. Does everybody know what JIRA is? Good. Because I could have gone back and explained, but yep. Then we have Confluence. Have you heard of this thing called Synchrony? Okay. Have you used Confluence 6? Have you used collaborative editing? So have you edited documents in live with another person? Okay, then you have not used Confluence 6 probably. So Confluence 6 came with this amazing feature where you can do same thing that you do in Google Docs, for example, in Confluence. So you're basically just typing with another friend to the document, and he's there doing it at the same time. And that happens on your server. It's done by the Synchrony part, which, by the way, in server is going to cause you problems if you have edits every second or so. We had some trouble. The database is now 70 gigabytes, up from 30. So it goes up, but that's why you have to go bigger. So once again, hardware became a limit. So what we did, we flipped it like this, and we have a Confluence node and Synchrony nodes, and they are proxied according to the URLs, and it enables us to offer high available system. So even if we decide to reboot during a day, Confluence, the users don't notice. So Confluence has this thing that if you keep editing enough, it starts corrupting their indexes. So if you have ever noticed that the search doesn't work in Confluence, how many have noticed that Confluence search starts to break down and you're like, why? Yeah, that's because it corrupted the things and you need to reboot the instance. Well, if you have server, you can't really reboot it on the fly because Atlassian kills the process if there is another process running. So data center. It enables us to do the boots during the day and nobody notices anything. We just notice it's getting slow, searches are not hitting, okay, reboot. And we can even automate that. So we've been bouncing around like automation of reboots and stuff. Once again, shared database, load balancer, shared file system. If you've ever used scaled systems, this is exactly the same architecture as everything else. Again, same thing, server license gets replaced and it becomes subscription based. Yeah, I know this is a sales pitch, but I'm getting to the good part. There's a lot of good gifts. And the price is again $24,000 per year. And then Bitbucket. So Bitbucket is the Git. I assume everybody knew Confluence. If you don't know any of some of the tools, you can ask, and I will go a bit and explain. I can even show it. We have a demo environments running. We have a Bitbucket installation where we have multitude of nodes taking in the Git clones and stuff. So if you know how Bitbucket works, you know that it actually, when you take a Git clone, it takes the whole repository to its to the machine's memory, and then you start pulling from it. So it means that if you have huge repositories, and you have accidentally, for example, pushed few hundred gigabytes of binary there, your server is going to crash. This might have happened, but yeah. We kind of noticed this, and we increased the memory once again, but it's not going to help if two people take the clone at the same time from two repositories that are huge. We need to start scaling. Like we do a lot of dockering, for example. So we can Docker, put it in Kubernetes cluster, and it keeps like growing as it needs. We have a shared database, shared file system, but on top of that we have Elasticsearch cluster. So we are running a search engine. So Bitbucket is the only one which has a search engine outside of the. I'm going a bit too fast. I noticed that I'm saying badly. Sorry, I'm a bit nervous because it's the first time I'm presenting this. So basically, it has a cluster which does all of the searches. So it helps us to improve the search speed also. So if we notice that search is getting slow, we add nodes to the search. once again, easy to improve, easy to manage and make us stay in SLAs that we agree with customers. Okay, to the good stuff. Why would I ever do it? So we have discussed about the high availability, the zero downtime upgrades, and nice things like this. Well, none of that actually matters to your IT. They're like, coders are going to code and they don't need the kit. Like, why would I keep my JIRA up and running? Like, one date here, one date here, isn't that's not going to matter. Like, it doesn't affect us at all. You go there with the numbers, this is how much money we lose. Well, they're like, no, that's how much our employees are doing stuff. Well, actually, I calculated that in 1,000 people company, if you have a 10% margin of consultants, well, that's a bullshit number, it's too low. And they are billing 100 euros per hour, for example. That's 600 euros per consultant per 6 hours of downtime. That's pretty normal to have 6 hours of downtime per year, usually a bit more. So with 100 users, it's 60,000 per year. Data center cost 24,000 per year. Math, like if you lose consultants' time, you're paying it. If you lose your employees' time, most companies don't care. But consultants, it's money. You're paying that. Like, I don't think if I need to say anything else about this. Like, it's it's a simple math. But yeah, there is also good things like high availability, the product leaking memory, performance getting better when you boot systems, zero downtime upgrades once again, and like improving the stability of systems, making users more happy. And usually when we do a data center installation, we also set up a single sign-on system to that. So there is like Azure AD and ADFS and those integrations. We have multitude of instances running those. So that saves again time because the user doesn't have to remember their password. If they don't remember their password, they're not going to get to that Windows machine. Because of course you have a Windows machine. I don't. So yeah, I was already going through this a bit. So I have this amazing set of steps for upgrading. I think we will be sharing these slides in the video, so you don't have to take pictures if you are not intending to use them tomorrow. So we are first phase when we started this all. We had to first, of course, design and implement and calculate how much it would cost. What's the benefits? Where would we go? What to do? And we designed the whole thing and calculated that it's going to take about 5 hours. That's the first phase. Then in the second phase, we tested the transition, checked the database volumes, checked everything. We had like everything done and checked. In reality, between this, we already did first upgrade and failed miserably because something changed. What changed? We put a maintenance window in front of our system, which means that the system couldn't call itself. So in Confluence's case, Confluence calls the Synchrony in different URL. What happens if you can't call the system? It crashes. Oops, weren't that hard way. Now our maintenance page understands that internal network communication needs to go through. Kind of, yeah, oversight from our part. Should have tested the maintenance page. Added that to our retrospective. And then we planned service break and document the steps that we intend to take. Possibly, we type an Ansibles and Dockers, so depended on installation and where we are going to do it. Some places we can't do all of it ourselves. So for example, in the operator, we are not controlling our load balancer. That means that they have a hardware load balancer that is operated by the load balancer team. They have the SQL cluster that's handled by the other team, and then they have the NFS that's managed by the other team. And we had to find time from all of these teams. Actually, we dropped the SQL the team and we just didn't tell them. We did our backups and stuff other ways, but yeah, we didn't want to work with them. Too slow. It takes a year to get the time slot with them. Kind of annoying, but that's what you get. And we set up everything and decided what to do. Then, fourth phase, we started migrating the data 3 days before with AirSync. If you know rsync, it's a copy command that enables you to move the delta. So that means that every time we rsync the data, we actually just move the delta. So attachments, we just move the changed files. This way, we didn't have to, like, when we started the migration, we didn't have to wait for 6 hours for the data to migrate. It was done in 15 minutes. And it takes longer for us to take the database backup. So the database backup takes about 1 hour from our Confluence, for example. So 1 terabyte of attachments, it's already moved. If you have you're just moving the delta. So then we start the downtime. We have the database backup. We kill the node 1. So the node 1 is the server node. We upgrade the node 2. We check that everything works. We bring up the node 1 if everything works. So we have already gone to production at that point. And at that point, we already know that we don't need to roll back. If it doesn't start as a data center, we can just kill the node 2 and boot up the node 1 because nothing is changed in the database. It's just licensing things and configuration file things. And then we boot the node 1 in during the day, for example. We booted it after a week of running the data center licensed version. And then we started hot upgrading, booting, and managing our clusters live. So that's short version of migrating. It's a lot longer phase, but I tried to make it simple. This was a nice timeline also. So I promised you fun little gifts. So this is my tales. So last promise, it was tales of data center, not me explaining you data center. So why? Well, we had these amazing load bounces. So as you can see, it just keeps bouncing and bouncing and bouncing. So we started to debug the slowness and cache hits and everything like that. And then we noticed that, okay, we have a fix for this, but it requires a reboot. It requires a reindex. It requires something that requires downtime or slows the server down. Well, in server mode, we were like, oh. And then someone did evening work or night work, depending on system. And as you probably know, the guy who does night work, for example, he's not coming to work the next day. So all of his work gets moved to other guys, and the stress keeps piling up. So once again, not fun. What we did, we just installed the data center. We kill a node, that node bounces. We start taking its logs, analyze them, figure out what's going on, and we can even directly tell the team that's doing it that, hey, please, your script bot is not working. Please fix your macros. So they were installing bad macros, and the page kept growing up, and they did that every second. So in the end, load bounces. And if it's something else, we notice it by gaining the massive load to the other node immediately. So if it's normal usage, we can boot up the other node immediately and start upgrading more nodes. If the load bounces because of heavy usage, like let's say everybody's all of a sudden going to Confluence to see Whitehair getting fired. Haven't seen that yet, but it's a possibility. Like everybody infos. This happened. So REST API in Confluence and JIRA can crash the whole system. So there are queries that you can do against the REST API that might break everything in certain versions. And yeah, the whole system crashes on single node. On 2 nodes, you kill the node that is running the heavy query, and you get ready to boot it again when the other node gets hit. But yeah, some people want to take all 5 million issues out of the system at the same time, for example, for analytics, and they don't realize that they are doing it in their live system. So yeah, it has happened. And again, pushing crap to the pages can start causing this. Also, you can crash the whole system by taking a MySQL dump. We did that also in one customer. Yeah, there's a lot of things that you can do wrong, but then you realize to check the configurations and the partners that are doing it and ask them how much memory, how much hard disk do you actually have on your MySQL? And they answer you, well, we might have like 2 gigabytes. We eat 2 gigabytes of memory database every day. Yeah, but we increase every day like 2 gigabytes. Yeah, it has happened. I like our partners, they are amazing, my favorites. Memory is running low, and yeah, this is where it gets hard. Like I said, Bitbucket uses a lot of memory. It comes from the fact that it's like, it's doing all kinds of stuff. So if you read about how to tune Bitbucket, you get some interesting math about how it uses the clone commands and how Git actually works. It's not fun to read as a sysadmin. It's a lot of text about, yeah, you're going to need about 6 times the memory that your biggest repository is. And when you get binary in the repositories, because Git LFS is hard, according to a lot of people, and I know a consultant, or actually a previous architect, who had a basic principle of putting everything into a CD disk. Jukka knows him also. He's a very fun guy who tells you a lot about backups, and that was his way of doing backups. Sad thing is, if you do that in Git, what are you doing? You're putting all the binaries in the freaking Git repository. Yeah. We told him to stop. He did, and he no longer makes 300 gigabyte repositories. Now it's like 10 gigabytes. We have a lot of Ansibus and all kinds of automation. It comes with the territory. Yeah, heavy memory usage. You want to configure your Java garbage collections. You want to probably reboot your Java after the heavy usage. Well, again, server. I'm kind of screwed. The next downtime for Git. When can you take a Git down? How often can you shut down GitHub, for example?
3 o'clock in the night.
Not in gaming industry. Not in gaming industry.
Not if you're running night ribbons or anything.
Yeah, if you're doing CI/CD, when can you actually turn off the database or the Git? You have everything shut down when your Git goes down. As I said, we'll get back to why it's mission critical for the operator. They are doing everything in code nowadays. They're trying to push everything into a code. That means everything is in the version control. That means that version control is down. Their whole development is down for count until that version control is up and running. And they are pretty big companies, like operators in general. And the more you go towards these, the more you face like all kinds of weird issues if you try to do it in single nodes. So scaling. And I still have 2, yes. Yeah, long-running queries eat the performance. So it's like healing yourself when you're dying. So you just try to keep healing yourself, and then the other long-running query hits. So database optimizations. This is something that data center doesn't directly involve, but at least you can kill the node that is doing the long-running query. So database, you can't really reboot it unless you have a Postgre database which is running in master mode, then you can. But yeah, requires you to have Postgre instead of Oracle or MySQL or MS SQL. Yeah, doesn't work every time. And my last slide, server crashes. Servers like to crash, for example, or for memory breakdowns. So if you have ever run hardware, it has these things called memories, RAMs, and they have faults. And then your bit hits that fault, and boom, the kernel goes. And there goes your server. You're pretty much screwed at that point on server, and in data center, we're like, yeah, one node died, next up. Because once again, our Confluence, for example, the home turned from what was it, Mika? 700 gigabytes?
Pretty much.
Yeah, 700 gigabytes to 10 gigabytes. So we have 10 gigabytes of restoration to do. Unless our NAS breaks down, and if our NAS breaks down, well, a lot of water data goes also with it, so we're anyway screwed. At that point, it might not be like the most critical to get those attachments. It might be more critical to get the NAS working again. And it costs money to crash, as I showed you in my amazing math.